Hello everyone, welcome to another Daily Spatial Dose. Today we will try to work with some Airbnb data that I have taken at random in Toronto. We have the ID, the name of the Airbnb, the description, a host ID, the host name, latitude, longitude, and price. This is a CSV file. You could have an Excel spreadsheet as well. And it's a very common structure where we have basically data organized by fields and columns. Now, one of the things that is important for us to note is that we have latitude and longitude values. And today we'll learn how we can convert these into a shapefile of a point so that we can do further analysis of the relationships with price. In case you haven't yet, your first step will consist in installing GeoPandas. So GeoPandas, as we've mentioned in a previous tutorial, is the library that allows you to handle spatial data in more advanced formats in Python. So to do that, just open up a terminal window and install pip install pandas geopandas. In my case, I already have it installed, but it's always good checking if everything is alright. So the first step consists of importing our libraries. We'll use several libraries to allow us the conversion into a point. Let's start with importing pandas. And you'll see that we'll import pandas quite often when we do any kind of analysis. The other would be the just recently installed GeoPandas, and then Shapefile, and particularly point function, because we'll convert the latitude and longitude coordinates into points. So let's import these to define as PD read CSV. And notice here you have different types that you can import: Excel spreadsheets and JSON files, among many others that you can use. By default, it shows us 5 rows, but we could change the number, for example, to 2 or 3 rows. So let's do 3 row. And here we have the latitude and longitude that we want. So it's important for us to note what the names of the variables as we define a function that will allow us to create the geometry. Let me just keep this here on the side. Latitude and longitude are the names of the variables. And it's these variables that we want to convert. So we create a geometry for those. So let's create a geometry, a row, and within that function we call the return of a point. The point will go into the row and check the longitude and the latitude. Okay, so we've defined that function, and based on that function we can apply for a new geometry column that we'll create called geometry. So we can do that in creating a new field, which is geometry. And we will apply this to create geometry, which is the function we have, axis equal to 1. Now it has read the latitude and longitude that we have and defined a geometry, spatial data that we want to create. So let's do that by going with GDF. So we can do and use GPD, which is the GeoPandas function, and in that we call the GeoDataFrame, which is what we want to convert it. We're going to convert the DF file. Actually, since we're at it, why don't we check out the data file again so we can see now how it looks like. Alright, and here we'll see that we have a new field created called point. So we have that. But it's a CSV file still, right? It's still a data file. So we want to change it into a spatial format. So that's why we call on the GDF, and if we go with GPD, which is the GeoPandas library, GeoDataFrame, and we call on data file geometry equals and what we've defined as geometry. So the geodata file reads as a file similar in its structure to the data file, but the interesting thing with that is now that we can start defining spatial properties about that file. So for instance, if we go and set the coordinate system, which we would have to, let's use WGS84. WGS84, which is the only code that I actually know by heart, is 4326. In many different things that you want to do, for example, creating the WebGIS and web maps and stuff like that, you will actually be using more of the 4326 code. So that's why I've memorized it by the many times I've used it. So we have now defined the projection. We want to do it in place, and we can go on, and now it's created the projection of that file. We can now define where we actually want to save the file. Let's say we are using the output file path as, and I'm just going to save it here in my data set right here. So I'm just going to copy the path here. And of course, instead of DSD Airbnb, it's going to be a DSD shapefile now. So this defines the projection, the output file path. And now we can call the GeoData file, which we created, and within that file we can use the toFile function, and we'll use the output file path, and we will use it as a driver Esri shapefile. Now that's important. The driver is what's going to be conditioning the format that we have. So in this case, we're going to use the Esri shapefile format. And let's just, for the sake of what we're doing, print out the shapefile saved to print it out to the output file path. So just to confirm that it actually did this. Okay, and here we are. So if you look at my directory now, it's populated with the shapefile that we have here. Imagine now that we've got this shapefile, if we wanted to visualize this into plotting it on a map, we could actually do that quite easily now. We would have to configure the understanding the figure and define the figure in its axis, plot, subplot. Oh, actually I had to call, I think I haven't called matplotlib as a library, right? So let me just go back here. Okay, I haven't called matplotlib. So to visualize it, actually I would import, and that's just for doing a simple visualization, nothing too fancy at all. And I would import this as PLT. Again, this is a library that we've used before. And once we've got imported this library, we can now define the figure in its axis, plot, subplots. And within the subplots, the figure size, I'm just going to go with the regular 1010 here. And now I can call the, did I run this? Okay, alright, it's run. I wasn't sure because it's giving me error here. It's underlining it, but I think it was because I didn't run it from the beginning of my script. So probably that's why. So GDF, and within GDF I can plot AX and AX color. Let's do color blue and marker as O, marker size, let's do 5. And now we can add a title to it. So set title as Airbnb locations. And now we can add, for example, the X label. And let's add the longitude. And then we can do the same with the Y label. So just here, Y label as latitude. And let's do that. We have sort of a grid underlying it, so it looks nice. And now we can actually go with plot show, and here we have the locations within the city of Toronto, nicely organized with latitude and longitude. Thanks very much for watching. Don't forget to press the like button and subscribe.